So, hi everyone. Welcome to the first episode of Cloud Talk series. I hope you're all safe and happy back home with your loved ones. So, first off, let me introduce myself. I am Amrita, and I'm the new lead for GDG Cloud KL. And so we're super excited to have you all joining us today on a Saturday morning. So to those of you who have already joined, feel free to say hi to us here. We'd love to know where you're from. And just keep it coming. We'd love to interact with you and get to know you all better. So today we have two amazing speakers. I'm sure that you've all seen our promotional materials and you're all as thrilled as we are. So first up, we have Wesley. So let me bring in Wesley to the live stream. So hi, Wesley.
Hello, can everybody hear me?
Yes, we can. So Wesley, thank you very, very much for joining us on the first episode of Cloud Talk KL. So before we start, we'd love to get to know you a little and also let us know what you're planning to share with us today.
Great. Hi. I'm going to introduce myself a little bit more formally in the talk, but I want to sort of give everybody in the audience a very broad overview as to the various different cloud technologies that we have within the Google Cloud organization. I think most people know that we have GCP, the cloud platform. We also have Workspace, which used to be G Suite and Google Apps. So I'll be covering all of those and showing you, like the different ways that you can use our APIs to access those technologies for your apps.
All right. Thanks a lot, Wesley. So without further ado, we'll get started with your presentation.
Great. Awesome. Thanks, Amrita. So again, hello, everyone. This is Wesley Chun. I'm a developer advocate at Google. Feel free to follow me on Twitter if you want to interact. It's also a great place to drop me notes if you have questions or anything like that. I will take Q&A afterwards, and I'll also give everybody a link to the slide deck, so you don't need to really take screenshots unless you really want to. I have a barcode and a short link up in the upper corner in case you're interested in, if for some reason the event is over and you have extra questions. This is just an open Google Doc that I have. Feel free to add, your public questions. And I check it from time to time. I answer. And then you can also scroll down and see other questions that people have asked me in previous talks as well. So yeah, let's get going because I'm going to overload your brains with lots of information. So my background as a developer advocate, my mission actually is to enable all of you, current and future developers everywhere, to be successful using cloud and other Google developer tools and APIs. I'm mainly focused on our serverless technologies at the moment, but I also work at advocating to higher education like universities and colleges. I also used to be on the Google Workspace team, so that's why I know something about that. I'm also pretty passionate about our AI and ML APIs. And more importantly, because I have all this background information, I like to come up with use cases where you can actually mix and match these different products and have them build useful tools together. So I'll show you some inspirational apps towards the end of the talk today. And most of what I do is I speak to developers like yourselves. I travel. I used to travel, maybe not this past year or so, but when I'm home, I do make videos. I write code samples. I make code labs, as well as write blog posts as well, too. My background is I've been a software engineer for several decades. Probably the most well-known thing I built, I was one of the original engineers that built Yahoo Mail about 20 years ago when I was a full-time software engineer. I also teach outside of work, and I've written several Python books, if you know that language. So that's me. So today's talk. So I'm really going to talk about the two main product groups that we have in Google Cloud. So that's GCP and Workspace. So most of us know GCP for, having VMs, big disk, lots of data processing tools as well as AI and ML. And then Workspace, of course, is known for its apps, right? But, the hidden secret is that it's also for developers too. And you can actually build pretty useful things if you use both of them together. So that's why the talk is called Building with All of Google Cloud, not just with part of the cloud. So I'll start by giving sort of like a high-level overview of what cloud computing is. just so that everybody's on the same page with the same vocabulary. Because, when you say cloud, it means 10 billion different things to everybody, right? So we want to sort of like normalize the vocabulary that people use to describe cloud services. And then we'll wrap up at the end. But in between, I will, after the overview, talk more specifically about the 2 product groups in Google Cloud. And then I'll jump into showing you REST APIs and specifically showing you actual code samples. And then we'll talk more about serverless platforms, and then to show those inspirational apps that I just briefly mentioned. Okay, without further ado, let's do this cloud computing overview. And this is vendor agnostic, okay? So it's not just Google Cloud, but it also applies to any cloud vendor. So this is just sort of like industry level vocabulary. So overall, what is cloud computing? At its sort of like the heart of cloud computing, it's really about outsourcing, whether you're outsourcing, hardware or big disk, or even things like applications. And one good example is one of the most famous applications that I have some familiarity with, and that's email. Right? A long time ago when the internet was young, did you know that in order to send and receive email, you had to have email servers, running on your machine, whether it be your desktop workstation or whatnot? But as the internet got bigger and bigger, it was not a great thing to rely on people that having to do this, especially when grandmother gets her first computer. You don't want her to manage SMTP on port 25. Really, that's not reasonable, right? So we have chosen to outsource our email service to a third-party vendor. So Gmail is an example where you've outsourced your mail service to Google, or if you use Yahoo Mail, then you outsource it to Yahoo, or Hotmail, outsourcing to Microsoft. So I'm choosing to have an email vendor manage those servers for me so that all I have to do is log in and get my email, reply to emails and things like that. Okay. So when we talk about cloud computing, we generally sort of like organize them or categorize them into 3 main areas. Okay, and the first one that we talked about, which is email, is outsourcing of applications. And that is typically called the SaaS level, or software as a service. You're outsourcing apps because you yourself don't want to manage those yourself, right? If you're outsourcing your customer relationship management system, then you would be a customer of Salesforce. Same thing goes if you use Google Docs or Office 365. You're outsourcing those apps to the cloud instead of buying them, installing them on your computer and all that stuff. They're all running in the cloud. And you can tell you're using a SaaS app when you have to physically go to a web browser or a mobile app and log in to get access to your data. So that tells you that is a SaaS app. Now, the other part of cloud that's very familiar with people is where you're outsourcing hardware, like machines, big disk, and things like that. So most cloud vendors have these. So you'll see like VMs and big disk and things like that, right? So that's pretty common and kind of like a commodity now, right? The one thing that I want people to focus on is that when you're renting a VM and big disk, what is your purpose? If your purpose is to run an application on top of that, well, guess what? You have other things you need to worry about. You have to think about, what operating system am I going to run? Do I choose Windows Server? If so, which version? Do I choose Linux? If so, which distribution? Which kernel version? So you have to make that decision. Then once you get that, then you have to decide what database server, what web server, what load balancer, all these things you have to think about before you can actually run your code. So if your purpose of renting a VM is to run an application, you may want to rethink, right, your decision. Maybe it's better to use the sweet spot in the middle, which is called platform as a service. So here, when you have platforms, you're more worried about your code. As the application developer, it frees you up from having to be a DevOps person, to having to think about machines and operating systems and all those other things that I mentioned. So PaaS is pretty cool in that sense. One thing that I do want you to think about is when you're uploading your application to run on a PaaS system, just be aware that what you're doing is you're creating a SaaS app, right? You're using a PaaS system, but you're creating a SaaS app because guess what? Your users are logging in to your app. So to them, it's a pure SaaS system, right? And of course, if they find a bug, like if I find a bug in Yahoo Mail or Gmail, I can't fix the bug myself because it's not my code. I have to file a ticket with a cloud vendor. Same thing goes for your SaaS app that you're running, that's running on a PaaS platform, right? You've uploaded your app and it's running and your users are using your SaaS app, but when they find a bug, guess what? They don't have access to your code. They have to file a ticket with you. So just be aware that you're using a PaaS system to host a SaaS app with. All right, and like any other large-scale systems, there's always gray areas in between, so cloud is no exception. So in between infrastructure and PaaS, you have systems which are more than the raw hardware, but they're not quite a full-on PaaS system. So, you can't exactly write an application that upload it to a cloud SQL system and run it, right? That's only a database. And you'll notice that most of the services here are data services like databases, data processing, data analytics. There's also machine learning and containers and networking and things like that as well too. Okay, so more than raw hardware, but not quite a PaaS system. And then similarly, in between PaaS and SaaS, you have these systems which I call restricted PaaS systems. So they're like their cousins in the middle layer here, but they are tied to data that live at the SaaS level. So while you can use AppScript and Force.com, you typically would expect there to be some kind of Google Workspace data or some Salesforce data, because otherwise you wouldn't be using these systems, right? You would be using something more general. So to me, that gray area is more of like a restricted PaaS system. Okay, so that's really the three main sort of like pillars of cloud computing. And if we were to take this and kind of like turn it sideways and look at it from the perspective of, who's responsible for what, at the SaaS layer, I've outsourced my app. I don't care what language it's written in. I don't care what operating system is written in. I don't even control the code, right? You've outsourced everything except for, like your personal email settings and things like that. So all of that is managed by the cloud vendor. There's really nothing that you're responsible for other than the personal settings. If you're using a PaaS system, well, guess what? It's your applications and the data that goes with those applications. And then you've outsourced everything else. For infrastructure, like I said, you've got the VM, but now you can decide on the operating system. You got to decide on, the database server, the web server, and all those other things in addition to your app. And of course, if you're not in the cloud, you're on premise, that means you're responsible for everything. Okay, so I hope that this is a great sort of like introduction to get people all talking the same language as far as what cloud computing is. And in that, everything will make sense for everybody instead of just like, oh, cloud is this, cloud is that, because everybody thinks cloud is something different, right? So this is the purpose of this part, is to get everybody talking the same way. All right, so with that, we are ready to move on to the next section, which is introducing Google Cloud. So what is Google Cloud? Well, it's an organization that I work at. We produce two well-known product groups. One is the cloud platform, which is all those, the VMs, the big disk, machine learning, the data analytics tools, all that is there. And then, of course, we have Workspace, which used to be G Suite and Google Apps. So that's Gmail, Google Drive, Calendar, DocSheet, Slides. All right, so those are two well-known product groups. Now, if I was to take these products and organize them into the cloud computing chart that we just looked at just a minute ago, it would look something like this, where anything that is SaaS flavored is going to belong to Workspace, because Google Workspace is a SaaS suite of products, right? And then everything from the PaaS layer and down, that belongs to GCP. So it's a very clear line. If it's any kind of SaaS flavor, then it belongs to Workspace. Otherwise, it's GCP. All right. So what I'm going to do now is going to give you a really high-level, quick tour of the probably more common products that people use in both of these product groups. And then we'll dive a little deeper into specific ones and then show you some code as well too. Okay, so we'll start with compute. So we have VMs, all kinds of different shapes and sizes. We support most versions of Windows as well as Linux. And by the way, at the bottom of every page, there's a link to the quote home page for every product. So if you can't wait, you want to go dig into those products right away, you can just grab that link and do that. So these are our VMs basically. I'll be spending some time in showing you the next product, which is App Engine. So this is where it's not a VM. You have code, you want to run the code, you upload it to Google, we take care of everything else for you. So you got an app, you built it, now you want it to run globally around the world. That's what App Engine is for. If you don't have an entire app, maybe you have just some small functions or some microservices, then Cloud Functions is perfect for you. So if you've ever used AWS Lambda before, this is sort of like our version of it. The interesting thing about Cloud Functions is that there's also a mobile version of Cloud Functions called Cloud Functions for Firebase. So that's why there's two icons down at the bottom there. And so the cloud one, of course, has greater connectivity to all the different other Google Cloud services, whereas if you use the Firebase version, you have access to lots of other mobile tools in the Firebase suite of products. So that's Cloud Functions. If you maybe have a containerized app and you want to run it serverlessly, that's what Cloud Run is for. So I'll show you a demo of that one. In fact, I'll spend a good amount of time on App Engine, Cloud Functions, and Cloud Run. And then if you do have containers, but you prefer to run it yourself, either on-prem, using Kubernetes on your own VM, I'd like you to consider our Google Kubernetes engine, where now you don't have to manage all the VMs. You don't have to manage everything in-house, on-prem. You will just want to outsource your containers to a Kubernetes service that's completely managed for you and taken care of for you. So that's GKE, or Google Kubernetes engine. So that's the last of the compute things I want to talk about. Obviously, we have more compute stuff, but these are sort of like the main players. All right, let's move on to storage, where to put your data. So first is where to run your code. Now it's where to put your data. So we have big giant disks called cloud storage. So that is your data lake for all your big blobs, because you know that all your data rivers flow into your data lake, right? Okay. We also have another product. If you're looking for something instead of a big giant disk to throw all of your data, maybe you're looking for a NAS or like a network, a NFS mounted file system in the cloud. That's Cloud File Store. Okay. So it's got a completely different use case, right? But anyway, it's a similar product. So at least I want to mention it. We also have relational databases. So we support MySQL, Postgres, and SQL Server. You can choose a little bit of your hardware configuration as well. So that's relational. Of course, we also have NoSQL as well, and that's Cloud Firestore. We used to have, our NoSQL solution used to be called Cloud Data Store. But what happened was when Google acquired the Firebase company and got access to the real-time database, we decided to take Firebase and turn that into an entire mobile development platform. So on top of the real-time database, we added all these other mobile dev tools like crash testing, mobile analytics, deep linking, app indexing, a virtual device testing. So we added all that stuff to Firebase, but the Cloud Data Store team really wanted those Firebase real-time database features. So what they did was they kind of got together with a team, and they were able to sort of incorporate some of those Firebase real-time features into Cloud Data Store. And so they merged them together and they rebranded it as Cloud Firestore. So it's the latest NoSQL, highly available, scalable data store that we have available for you. Okay, so that's Cloud Firestore. I'm going to jump to machine learning, where you can analyze your data. So we have a really awesome tool called BigQuery. This basically lets you analyze multiple terabytes of data with just simple SQL. All right, you have a data set that just cannot fit into a relational database. You can throw it into BigQuery and just issue SQL calls on it. It's great. I'll show you a demo of this one too, and why it's a really awesome product in more than one way. So I'll keep you in suspense for now. We also have a translation API. So if you're trying to, translate from, Bahasa to English or vice versa, this is the API for Google Translate. We also have the Cloud Vision and Video Intelligence API. And by the way, the next speaker is going to show you some of these APIs as well, a little bit more in depth. I'm going to give you sort of like a really lightweight code sample soon, but I'm just going to walk you through these products really quickly right now. So Cloud Vision and Video Intelligence are the next one. So this allows you to understand the contents of images and videos by extracting the appropriate metadata that you're asking for so that you can basically index them and make them searchable. So they're pretty cool. There's also the Natural Language API. So this allows you to understand the structure and meaning of text. It can do things like sentiment analysis. Is this text positive or negative? It can classify content like this is scientific data, this is legal data, this is financial data. It can extract entities like, like KL is a city, Malaysia is a country, Google is a company. It knows how to recognize syntactical structure and things like that. It also supports multiple languages. So I think Bahasa is supported by some of these. I don't know if Bahasa is supported by all of them, but I'm pretty sure there is some Bahasa support, whether it's the Malaysian version or the Indonesian version. I know there's some support because I've seen it. All right, so that's machine learning. There's also Cloud Speech API, so you can convert audio speech like what I'm doing now and get that into strings that your code can process, or vice versa. You can take existing text strings and then put a voice behind them. So that's speech to text and text to speech. And then the last one I want to talk about is not specifically an API. It is sort of like an enhancement on some of the existing APIs that we have, like, for example, translate, vision, natural language, video intelligence. Those are all great, but you should recognize that they're based on pre-trained models that Google scientists have created. So while, for example, the vision API knows how to recognize common objects like, birds, cats, planes, dogs, and things like that, if you have specialized data, like maybe you want to identify all the flower species in Malaysia, or maybe you're you're architect and you have construction blueprints, or maybe you're a doctor that's analyzing medical images, the Vision API as is not trained for that type of data. So if you want to create sort of like a customized version of the Cloud Vision API model for your type of data, use the AutoML version. So that's the the icon right below it. So the AutoML version of Vision will allow you to take our existing Vision API model, and it will allow you to train and customize that API for your data. And you don't really have to be a data scientist to use it. So that's why it's really popular and people like it, because you just, if you're a regular application developer, you basically have enough skills to be able to use AutoML to train a special version of the API just for you. You really just need to get a hold of enough data to actually make that model worthwhile. So that's AutoML. And the last one is Workspace. So Workspace has a whole bunch of apps, right? Everybody knows about Google Docs and Sheets, Slides, Forms, chat, and things like that. But a lot of people don't know that there's APIs behind all of them. And there's also a separate high-level programming platform called AppScript, which I will show you as well, too, that lets you code it without having to think about APIs. So that is what I'm going to show you. I'm only going to walk through a couple of the APIs that I'm going to demo. I'm not going to demo all of them, like Gmail and Calendar. I'm skipping those, so you won't see them in the next couple of slides here. So I will show you an example of Drive, so where you can obviously read and write files to. You can control, who gets access to your data. You can also import, export. Like, I want to export a Google Doc as PDF. I want to import CSV into Google Sheets. You can do all of that with the Drive API. And then, of course, a spreadsheet is the most programmatic of all the Office developer type tools, right? So obviously, Google Sheets, along with Google Maps, are the two of the oldest APIs that Google has. And I think they launched, like 15 years ago in 2006. So obviously, I want to show you an example of using Google Sheets. As far as chat has been interesting, because of pandemic, people are using Meet and Chat more. And with chat, you can actually write bots, which are very useful to think about, because, with a simple chat message, you can actually create a bot that does interesting things like check the weather in KL over the next week, or, check the weather in Singapore because I'm going to fly there for work at the end of the week or something like that. You can actually do a lot of heavy lifting from a simple chat command, make it go and fetch all kinds of data and then reply back in the chat room. So I want to show you an example of this too, because I think it's pretty cool. All right, so that's it as far as sort of like high-level overview goes. Let's dig into actual code snippets using GCP and Workspace APIs. I will give you a heads up that we have two different styles of access. If you're using an API where you're accessing public data, well, I'll talk about examples, but if you're accessing public data, it's not private data, then all you need is an API key. If, on the other hand, you do want to access data that belongs to a human or another application, then you need to have authorized access. All right, so if you want to code with Google APIs, you do need to go to the Cloud Console. So that's console.cloud.google.com. Everybody has one. Even with your Gmail accounts, you have access to it. You just log in with your Google account and you get access to the console. So this is where all the developer activity happens. What you'll find in the console, so first is this section down here. So these are all the GCP products that you can use. Because this console was made specifically for cloud platform stuff, this is where you sort of like manage the usage of whether you got VMs or big disk or you're using data storage or whatnot. They're all down here. And this is, I cut it off. This should be like a dotted line down here because it keeps on going down, 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 because there's like security, networking, all that kind of stuff. So lots of stuff. It's also where billing happens. So most Google APIs are free, but not the cloud ones. Okay, the cloud ones are more like your electricity. You get an electricity bill, you get a phone bill, you get a water bill. Okay, so it's pay per use. So whatever little bit you use, you pay a little bit. And a lot of the cloud products have a free tier, so you have to exceed the daily or monthly free tier in order to be billed. So don't be scared that we're going to start charging your credit card right away. But other APIs that Google has that are not cloud are free. And typically, like if you have a Gmail account, then the Workspace APIs are pretty much free, up to a certain limit, right? So using Drive, Gmail, Sheets, all those APIs, they're pretty much free. Google Maps, they give you like, $200 of access free every month. YouTube APIs are free. So there's most Google APIs are free, but not the cloud ones. So that's why there's a billing section. There's also IAM and admin. So this is identity access management. That's what IAM means. So this is like where if you have multiple developers that are working on the same product, you want to get them all in the same project, building the same app and things like that. You can control the different access. So that's what the IAM is for, is to control security as far as what your developers get, what users get, and things like that. And then the last thing, most importantly, is how to manage your APIs. So managing your APIs happens with the API manager, or developer console, as I like to call it. And let me show it to you here. So when you click on this and go to the dashboard, you get this. There's also another link that you can go to it directly without having to go through the Cloud Console first. So that's the API Manager or Dev Console. So here you have 3 different tabs. So the first tab you see here, this is your application dashboard. So you can see how much traffic is my app getting, how many errors is my app generating, and then like how fast do I typically respond to my users. And then down at the bottom are a list of all the APIs that I've enabled to use. We don't turn on all APIs for you by default. You have to pick and choose which APIs to use. For this app, you can see that it's using the Calendar API, Google Drive, Google Sheets, and a YouTube API. Okay, so that so anyway, so this is the front page. The second page is the library page. That's where you get a big search bar and you type in what APIs you want to use. Like I want to use the Google Sheets API. I want to use the Cloud Vision API. You just start typing the word and then it shows you all the matches, and then you click it, and then there's a blue enable button. You click that and then you're good to go. Again, the cloud ones cost money. So if you enable one of the GCP APIs, it will ask you to create a billing account and you have to punch in a credit card and things like that. Okay, and then the third tab is credentials. So I mentioned earlier, you can use an API key, or you can use OAuth for authorized access. So I'll mention that momentarily, but just know that there's a page where you actually manage your credentials. Okay, and by the way, anytime you see a blue box with a little thingy, a short link in there, that means I've made a video on this, so you can actually go and follow up and kind of get more details as to what else should you need to know about this. So that's what the blue box is for. All right, we support lots of different languages. So I'll give you demos in Python and JavaScript. They seem to be pretty popular, but whatever language you're using, it probably is supported, hopefully. It's one of the ones listed on this page. And then there's some links to get access to some of the client libraries. Okay. All right, so I want you to know a little bit about how the APIs work, okay? So Google APIs work in a request response workflow. So that means your application makes a request, and then we have to, of course, make sure that you're authorized to get access to this API or the data and things like that. Once you pass a security check, the API does what you need it to do, and then it responds back to your app, okay? So it's a very client-server type model. All right, so let's look at some source code. So the first one is Google Drive. So this is a Google Drive application that all it does is just list out the first 100 files and folders that are in your Google Drive. And believe it or not, this application is only the bottom 4 lines. It's only 4 lines long, okay? So it's not that hard to write some code to analyze what's in your Google Drive. The top part is just the imports. So this is Python, of course, but no matter what language you use, you're going to have some kind of imports, right? And the second chunk is just the security code, right? Because guess what? Is Google Drive an example of public data or private data, right? I mean, you can probably guess that this is not public data because this data belongs to a human, which means it has to be authorized access. So you actually have to, ask the user who owns the data for permission for your app to access their data. All right, so that's what this whole middle section is for. I want to get read-only access to the metadata of your Drive files. All right, so that's what this part is for. And then the bottom part is once you, have the credentials, then you can connect, create a service endpoint to the Drive API. I want to use the Drive API version 3. Here are my credentials. And once you have that service endpoint, I could say, hey, Google Drive, please give me a list of the top 100 files and folders. 100 is a default. I could say something like max results equals 25, where I only get 25 files and folders, right? But if you don't give it anything, it defaults to 100. Execute the API call and get the files, and then I loop through all the files. For every file, give me the name of the file and then what type it is. All right, so this is pretty basic. This is probably the shortest demo you could possibly get. And I'm going to leave out all the security imports in all upcoming code samples because I don't want it to take up the same space. All right, and then there's a video for this one that you can take a look at. So why would you consider the Drive API? What can you use it to do besides, import, export, PDF, CSV? What else can you do besides upload and download? Well, guess what? If you have a bunch of pictures and maybe, after coming back from vacation, maybe your camera's memory looks something like this, right? It's a huge stack of photos. You can't organize it. But guess what? If you use the Drive API, you can scan the metadata of each of the files, and you could possibly automate creating photo albums for, the family trip here, winter skiing trip to Japan, or whatever, right? So that's like one thing you can do. And then maybe you can take those pictures and put it into a slide deck and create a slideshow. And then maybe you can take that slideshow, turn it into a video, and then upload it to YouTube with the YouTube API. And then maybe you can send it to your relatives by using the Gmail API to send it to your mother, father, grandmother, aunt, uncle, or whatever, right? So I'm just sort of giving you some ideas as far as like what you can do if you just use some imagination and what kind of APIs you have access to, okay? All right, so now moving on to spreadsheets. Why would you use a Sheets API? It's obvious, right? A spreadsheet is a very useful tool. I want to get data into it. I want to get data out of it. Like maybe I have data in a relational database. Maybe I want to take some of that, move it into a spreadsheet. Or maybe it's the other way around. Maybe I'm having users do data entry into a spreadsheet, and maybe I want to back up the spreadsheet to a relational database. You can go either way. Okay. Another cool thing the Sheets API allows you to do is make charts and diagrams, right? Because if Google Sheets can do it, you can probably write an app to make it happen automatically. So if you want to learn how to use the Sheets API and you know JavaScript, and you can try out this cool code lab. My coworker wrote this, where you can create a Node app that creates a customized reporting tool. So it's pretty awesome. It's about half an hour long. It's pretty quick. So here's an example of like, I want to take something from a SQL database and I want to drop that stuff into a sheet. So by the way, the code lab here is creating a reporting tool for a fictitious toy company. And so I'm actually going to borrow that same toy order database from that sample app and into this code sample. So I'm going to download the toy orders using this SQL select star from all the orders. And then I'm going to add the column names because, relational database doesn't have the column names as part of the data, but I want to put that in my spreadsheet first. So I insert that as row 0 before all of the data. And then the next couple of lines of code. So assuming I pass all the credential stuff, this is the code that you don't see. I said I was going to leave out, right? Once I have an endpoint to the Sheets API, I could say, hey, Google Sheets, please create me a brand new spreadsheet called customer orders. And here's the data, and please return me the spreadsheet ID because I want to access it later. So then you execute the API call, and then you get this spreadsheet ID back, save it into spreadsheet ID. And now that I've created the spreadsheet, I want to upload all the rows into it. Okay, so this call says, I want to take spreadsheet ID for the spreadsheet I just created. I want to start at cell A1, and then I want to take all the rows and I want to write them like raw straight into the spreadsheet. Okay, so that's that. And there's also a video behind that one. Moving on to cloud. So this is BigQuery. So this is the cool tool that lets you analyze multiple terabytes of data with just simple SQL. So this is just an example of all the works of Shakespeare. So, honestly, Shakespeare only wrote in plain text. He didn't have multimedia. So this is not an example of multiple terabytes, but it is, I think it's like 40 megs in plain text, which is quite a bit for a human to go through. And, if you were given this assignment at university where your professor asked you to list out the top 10 most common words that Shakespeare ever wrote, that is not something you want to do as a human, right? You want to write code to have that happen. So that's what this SQL query is for. So it does a case insensitive search, adds up the count for all the different words from the free public data set we have for Shakespeare, and then group by the word, order by the count, and give it to me in reverse order from top 10 coming down. All right. Anybody have a guess as to like what are Shakespeare's most common words? I mean, in English, you can probably guess what they are already, but the rest of the code here just makes that call to BigQuery and then displays the results. So if your guess included the or and, then you would be correct. And look at, there's 30,000. Can you imagine like writing 30,000 times on a piece of paper while you're counting all the words that Shakespeare wrote? Not a fun experience, right? Another cool thing about BigQuery is that there's this cool web UI, so you can actually perfect your SQL in here. Once you have the correct results down here, you can download it as CSV. But even better is you can take your query out of the web interface and drop that into your source code, because you can use it right away once you get the right query. Okay, it's pretty awesome. So why is BigQuery so awesome? Because it has a lot of free public data sets. In fact, BigQuery is the only cloud product you can use completely for free every month with no credit card. Okay, so every user that has a Google or Gmail account can access 1 terabyte of queries in BigQuery using the BigQuery sandbox for free every month. No credit cards. It's great. And we have a lot of free public data sets, so you can do lots of cool queries, just like the one I did for Shakespeare. But we also have like free data sets like all of Wikipedia, all of GitHub, like weather station data, hospital data. So there's lots of different things that you can do. And maybe your government even has made some data available too. Okay. But the cool thing is that the data that's hosted on BigQuery, you don't have to pay for. When you're importing your own data, you have to pay for storage. And same thing goes for if you're using other public data sets from Google that are not hosted on BigQuery, you actually have to pay for that storage. So just keep that in mind. And of course, since coronavirus is a big deal, there's a lot of coronavirus data sets in BigQuery as well. And then, this is not related to this talk, but just in case you didn't know, Google Cloud has some healthcare related APIs. So there's a life sciences API that does genomics processing. And there's also a healthcare API that helps move data between different medical systems and things like that. So you can read more about those two down here, as well as read the blog posts about them. All right, moving on to the Vision API. So the speaker that's coming after is going to give you a more in-depth example, but the Vision API, like I said, just gives you understanding as to what is inside an image. So what this does, this code will just look at an image and detect what are the objects that are inside it, as well as provide a confidence score of how likely this object is in it. And then also I've asked to do some facial annotations, like what is the facial gestures that this human is showing inside the picture. Okay, so here's an example image here. It's a gentleman, and apparently it's 97% chance there's a table in it, 96% chance there's furniture, 95% chance there's a smile, and so on. And then as far as facial features go, it's very likely there's joy expressed in here, but none of the other ones are very likely. Okay, so this is just a high-level demo of Vision API. This is only two features of Vision API, facial features and label detection. There's a lot more. I updated a code lab, which is a self-paced hands-on tutorial that teaches you 4 different features of the Vision API. So you can try it at that short link there. All right, so let's move on to serverless. All right, so I mentioned earlier that we have VMs and big disk, right? You can get a free VM every month. I don't know if you all know that, but everybody gets a free small VM that's called an F1 micro. It's like, it's like 2 gigahertz CPU, 4 gigs of RAM or something like that. And everybody gets one free per month, all the way up to a massive, gigantic VM that has like 416 vCPUs, 12 terabytes of RAM, and up to 256 terabytes of disk. So of course, this is a very expensive machine. It's like, it's more than like $80 per hour. So, you probably don't need that. I would just stick with the free one for now. But in case you get a job at a big, giant, scientific organization where you do need something big, then, you can obviously get it. So we have crazy VMs, small size, giant size, and we have big disk. But why? Remember how I told you earlier, if you want to run an application, there's too much work that you have to do in between all of the middleware, right? The operating system, database server, web server, load balancer, all these different things you have to worry about. So that's why I want you to consider serverless instead. So of course, serverless is a lie. Of course, there are servers, all right? But the main thing is that it's not your problem. Okay, you just let other people handle it so that you can focus on developing the solution you want to build. So why would you consider using serverless? Well, according to one analyst in 2018, they have projected the corporate spend on serverless to be doubling every couple of years. We'll see, I don't know. These numbers are pre-pandemic, of course, so I don't know if we're going to be at 8 billions at the end of this year, but we'll see, right? So anyway, so serverless is great at being able to handle the job of DevOps for you. You just worry about your code and then we run it for you. Now, usually when you create a solution, we always tell you, oh, do the 80-20 rule, right? Make sure that your solution works for 80% of all the use cases and don't worry about the 20% corner cases because you can fix that later, or V2 or whatnot, right? But the cool thing about serverless is that we can also handle the other 20. All right. So for example, what if you go viral, right? If you have a small company and you didn't spend enough money buying hardware, at some point, if your users, get more and more, viral with your app, at some point, your new users are not going to be able to reach your system because it's inundated with so much usage. Then your old existing users are not going to be happy because they can't reach your app either, right? And so you're not going to have a good future if nobody can reach your app. Right. So auto scaling becomes your new best friend because now you don't have to worry about it. Google Cloud will automatically scale how many instances of your app are running. So as your traffic goes crazy, the number of instances that are serving your app will also grow as well. And then the opposite is true. What if you spent too much of your startup money and you bought too much hardware and you're not getting any traffic because maybe you should have spent that money on hiring smart engineers like you guys to go and build those applications, right? Maybe you're not getting any traffic. Well, the cool thing about serverless is that unlike VMs where you have to pay for the VM 24/7, with serverless, you can scale to 0, right? If your app is not getting any traffic, your code is not on any instance. Therefore, you're not getting billed. Therefore, you're not paying. So if you get no traffic, guess what? It's free for you, right? So that's another reason why serverless is so cool. All right. So what are some of our serverless tools? The first one is App Engine. This is where we can host your app in the cloud. This is app hosting in the cloud. So why does App Engine exist? Well, easy. A long time ago, when we first created our very first cloud product, App Engine, the development team went to ask all kinds of users around the world, what is the hardest thing to launching your service globally? And they said all these different things, right? The operating system, the machines, the database server, web server, all these things get in the way. And guess what? All apps need to have these things, not just your app. All apps need these things. So why can't we make it so that we handle this stuff for you? All right. And why don't you make it available in lots of familiar languages that people can code to? And why don't you make it auto scaling as well? Because that's really expensive to build too. And why don't you only charge us whenever, we get traffic, right? So all these are the wish lists. And so the product team put together all these little brown boxes into one giant box called App Engine, made it available in lots of well-known languages. And so here's your Python MVP, or minimal viable product, the world's smallest web app. So you have a config file here, you have your main web app here. It just does hello world when you go visit the web page. And then here's the packages that I need from Python. And then once you have your source code and you download the Google Cloud SDK, all you need to do is just do G-Cloud app deploy. And then in less than 1 minute, typically less than 1 minute, your app is available around the world, fully scalable in case you go viral. You get a free URL with it, but of course you can map your own custom domain as well. And so this is a quick start example, and you can try it out at the link down there. So that's App Engine. Now, Cloud Functions is function hosting in the cloud, where maybe you don't have an entire app. Maybe you just have small functions, or maybe some microservices, right? So that's what Cloud Functions is for. And on top of that, it does what App Engine does, but it also does a few things App Engine cannot do. So those things are in bold. So one thing that App Engine currently does not do is it doesn't do background events. Like I have to go and visit the website or have my mobile app calling the app in App Engine to make it run, right? But in Cloud Functions, I could say, hey, if I get a message through Cloud PubSub, which is our message queue service, it's kind of like Kafka, if you've ever used that before, or maybe somebody uploaded a file to a cloud storage bucket, or maybe somebody logged into Firebase, I can make Cloud Functions run based on those events, okay? So that's cool. And like App Engine, it auto scales and it's pay per use and all that kind of stuff. You can code on the command line just like App Engine, but you can also code in the console. I can create a Cloud Function in the console, in the Dev console. I can code in the Cloud console. I can deploy in the Cloud console. I can test in the Cloud console. So you can do everything in the Cloud console. But if you want to develop locally, I recommend that you use the functions framework, which is a thing that lets you deploy and run functions locally, so you can have everything tested before you upload it to Google Cloud. And then, like I said earlier, there's a Firebase version of it. And then we support lots of different languages as well. So here's your Python MVP. So this is hello world. The G Cloud deploy line is a little bit longer because you don't have a config file now, right? You just have 2 lines of Python code. This is the world's smallest function, right? And then in under 60 seconds, usually, just like App Engine, your function is available around the world. So you can curl to it or HTTP to it, or if it gets triggered by other background events, you can get it to run. So this is part of the Cloud Functions Quick Start. All right, so let's move on to container hosting in the cloud with Cloud Run. So containers have gotten really popular over the last few years. Why is that? Well, because it's very flexible. It lets you put together everything that you need, like your operating system, your web server, your application code, any kind of dependencies. It lets you kind of bundle those together in a recreatable package. So I can throw this on a VM. I can take this container image and throw that on a different VM, or I can deploy it to a GKE fleet of VMs using Docker and Kubernetes, right? So it's become an industry standard. Now, for serverless developers, they've never been able to do this kind of stuff, right? You saw App Engine and Cloud Functions only support certain number of languages. Well, what if I want to do things in C? What if I have a C++ imaging library, or I have some kind of binary? I can't use serverless, or maybe if I'm writing App Engine only and Cloud Function only code, maybe I can't easily move that to other platforms. Actually, that's not true. You can pretty easily, but maybe. Okay, so why do I have to choose between the flexibility of containers and the convenience of serverless? Okay, so that's been sort of like the problem for many, many years. And as many years as containers have been around. So that's why Cloud Run exists, because it allows you to deploy containers in a serverless way. Okay, so unlike Kubernetes, where your servers are up all the time, your container in Cloud Run is only running when you're getting traffic, right? So you have the flexibility of containers where you can use any language, any library, any binary. All we ask of you is that you leave an HTTP port open for us, for Cloud Run to call your container, as well as making your container stateless. Okay, and then you bundle that into a container using Docker or Cloud Build. It goes into the container registry. Then you can deploy to Cloud Run pretty easily. We also support GitOps, so that you can make it so that if you do a check-in on Git and you do Git push, it'll start a cascading chain of events that leads to building your container and deploying your container. So, so it's pretty awesome. All right, so that's Cloud Run. So here's your MVP. It's almost identical to the App Engine demo. The only difference is that now I have to kind of like look at starting a server on port 8080, because that's what Cloud Run is looking for. We have quick, it supports any language, any library, any binary, but we have quick starts in these 10 languages here. And this is part of the quick start here. And of course, if you do know Docker, you know that there's a Docker file, a Docker ignore, and things like that. But if you also know Docker, you probably know it's sometimes challenging to create a good Docker file, because you can make a really bad container image, right? So Google Cloud is making that easier by using build packs, where you don't have to have a Docker file. In fact, you don't even need to use Docker at all. All right, if you do this one-line technique, it will go and introspect your source code and figure out what packages you need, and it builds your Docker container for you, so that you don't have to think about all the hard work it takes to do a Docker file. So that's why I think it's pretty cool to use these things called build packs. So that's what that is. And again, in under a minute, you will have a running container at a special URL that's been given to you. All right, so between these three, people ask, so when do I use App Engine? When do I use Cloud Run? When do I use Cloud Functions? And so typically, this is what we tell people. Of course, you could probably put check marks in all the different boxes, but these are sort of the more common use cases in which products we recommend. All right, last one, and then I'll wrap up. So AppScript. So AppScript is a customized serverless JavaScript runtime for automation, extension, and integration with Workspace, as well as other Google and external services. So this is a higher level platform. It's only available on the Workspace side. So we've kind of left GCP a little bit, and we're moving to serverless on Workspace. So using this is very different from using APIs, as you'll discover. It's more like objects, not like REST or HTTP and OAuth and things like that. So for example, to talk to Google Sheets, you don't have to go through that, user scope permission, getting credentials and all that stuff. All you do, here's a one-line JavaScript application, a one-line application, okay? I just broke it up into 4 lines so you can read it easier, but this is a one-line application. So to talk to the Google Sheets API, you just say spreadsheet app, dot. Then I want to get the active spreadsheet I'm on, dot. I want to get cell A1, dot. I want to put hello world into it. That's it. This is a one-line JavaScript application. You save it, you run it. You still get the OAuth permissions, because you still have to give this code permission to access your data. So OAuth is there. The difference is that, the AppScript system writes the OAuth code for you so that you don't have to as the application developer, okay? But you still get prompted. And once you answer yes in the OAuth prompt, then you'll see hello world in your spreadsheet. And it's pretty empowering, right? Because you know that code did that. You didn't type that in manually as a human. All right, so AppScript is pretty cool. So here's a video to introducing you to that. But that's not really useful, right? So this is more useful. This is an actual address of the Google New York office. And so let's blow up our app from 1 line to 4 lines, okay? So look at this. Now I have 4 lines where I'm asking Google Sheets to give me what's in cell A2. So I'm going to read the value. Then I'm going to save it in address. Then I'm going to say, hey, Google Maps, can you make me a new map and put a pin on this address? And then line 4, hey, Gmail, can you email this map to my friends so they can come to the Google New York office and join me for lunch? All right, so this is a 4-line application that touches 3 different Google products, right? So, it's not that useful, but it's much more useful than Hello World, right? So you can kind of like use your imagination what you can do with it. So now I can write an application that maybe my sales team is visiting their top 4 customers in New York, or maybe I have a book club that meets every month, or a user group meeting, like GDG Cloud, right? Maybe I can manage it with that. Maybe I can use Google Calendar and stick invites into everybody's calendars, and maybe I can use a Gmail API to send reminders. Hey, the meetup is this week, right? So you get an idea. I'm trying to inspire you, okay? And then you can do crazy things like, in Gmail, I get all my expense reports, but now I have to cut and paste into a Google Sheet and then send it to my boss. Why can't I do this all in Gmail, right? So my summer intern in 2017 wrote this cool Gmail add-on that basically reads the contents of an email out. This is in Gmail. You can actually see that, right? It extracts the information. You just click yes. By the way, it works on mobile as well, too. So he has this. You look at the form. You say, OK, go for it. So I'm going to do that. It logs successfully. And boom, after you're done, I have an entire spreadsheet full of all my expenses. And now I can send it to my boss who will approve it, and I get paid back, which is pretty awesome. So that's a Gmail add-on, and it's done, written with AppScript. All right. And then if you're a hardcore developer, you don't want to use our built-in editor, you can do everything from the command line and use the class tool. All right. And then I just want to show you a couple of things on bots, and then we'll wrap up. So Hangouts chat bots. So it's cool to be able to write bots to do all these things like look up a restaurant, or find out if somebody's busy, or find out whether or not someone's done the task that you asked them to do. Pretty easy. Writing chatbots is pretty simple. So you can do it with Python and Flask. You can use all Google Cloud products to create bots with. So this is just a Flask app that reads the contents of whatever message I sent. It says hi to whoever sent the message, and then just repeats what the message was. So that's the Flask version of it. You can do it with Node using Cloud Functions, regular Google Cloud Functions, or Cloud Functions for Firebase. So you can use this with your mobile app. Pretty simple, same thing, but it's in Node. Or I could just do it in AppScript using only 1 line of code, which is pretty easy. So this is all 3 of these are the exact same app, one using Python Flask, one using Node, this one using AppScript. Okay, so pretty easy to write a bot. It's pretty cool. All right, so let's wrap up with some inspiration. I'll give you some links to kind of like go and dig into this information. So inspirational apps. What happens when you use both GCP and Workspace together? So my colleague wrote an app that analyzed, he basically wrote an app that added custom intelligence to Gmail by analyzing Workspace data using GCP. So what did he do? So he goes, oh, you know what? I get a lot of emails. It's crazy. But, while Gmail does a great job of filtering spam, even with my non-spam, I only care about certain messages. And his use case is messages that have attachments with pictures of birds in them. I know that sounds really funny, but just bear with me here, okay? So his app works like this. Whenever a new message comes into his Gmail inbox, it notifies Cloud PubSub, which is our message queue, right? So our message queue system will call a Cloud function, which will extract the attachments from the email message, calls Cloud Vision to analyze the contents of those images. And if bird is one of the labels that comes back, then I'm going to call the Gmail API from the Cloud function and star that message so that the next time he logs into his Gmail, then some of his email messages are automatically starred because there's an attachment with a picture of a bird in it. All right, pretty cool. He didn't have to run it, right? It just happened automatically in the background. So that's the magic of Cloud Functions. So if you want to learn how Gmail can forward to PubSub, there's a link there. If you want to learn how PubSub can kick off a Cloud Function, there's a link there. But really the main idea is that Cloud Function orchestrates all the things that are happening. You can read more about this sample in the blog post, or you can just go grab the source code, take a look at it. The last example I want to talk about is doing big data analysis using GCP tools from Workspace. So it's going in the opposite direction of the first app. So big data is everywhere. And I showed you how cool BigQuery is and how you can do all this analysis. But, the CSV, when I'm done, that's not pretty to look at. It's like these stairs, right? I could use them. They're 80% done, but it's not pretty, right? CSV, who likes reading CSV? Not me, right? I would rather, if I was your boss, I would like to see it in a spreadsheet because that's easier for me to read. And if I'm using the Sheets API, I might as well tell it to make a chart because charts look good to bosses, right? And if I'm going to make a presentation to my boss, well, why can't I just read that data into a slide and maybe import that chart that I just made as well? In fact, why don't I just make a slide deck all in one program? Okay, so that's the whole idea for this app. So it's an app script app. I'm sitting there. I click the run button in my app script app. It goes and calls BigQuery, gets the results back, sticks that into a sheet. I tell Sheet to make a chart. And then I say, hey, make a new slide deck, import the data and the chart into that slide deck. And boom, I went from big data analysis all the way to exec-ready slide deck. And this example, if you take out all the comments and blank lines, it's less than 100 lines of JavaScript. Less than 100 lines. It is not that hard. You can take this and make it something awesome. All right. So I created a code lab so you can build this line by line. I also made a video and a blog post for you, and also talked about both of these apps at Cloud Next in 2018 and 2019. And to wrap up, let me give you some links. I'm not going to read them to you, but there's a links to get started. Intro code labs, documentation, videos, code samples, free trial. If you know AWS and Azure and you're curious about GCP, there's a link down for you there too. And then some other APIs. I don't have time to go through all these because I'm running out of time, but we have lots of other non-Cloud Google APIs that you can use. One, you should take, I told you about Firebase already. Data Studio, if you've never heard of it, it's a great way to build a beautiful dashboard on top of any data source. So that's pretty awesome. Voice-driven apps using actions on Google, YouTube, Maps. Flutter is where you want to write a mobile app for Android and iOS with one code base, also a web version too. So you get all three, only one code base. So look at Flutter. And so to wrap up, Google Cloud has many different tools and solutions. Workspace gives you the business apps, collaboration, communication, productivity tools. GCP gives you all the hardcore cloud processing stuff, but they both have serverless platforms. And it's great that you can use them both together, right? Because you can build more powerful stuff if you use all of cloud, not just part of cloud, okay? And you can build great solutions for yourselves as well as for your customers. And that is it. My Twitter is here. Feel free to follow me. If you notice the progress bars down at the bottom to show how far I was along in the presentation, it's because Google Slides doesn't have progress bars, neither does PowerPoint, right? But guess what? This is a Google Slides add-on that my colleague wrote to add progress bars to Google Slides. So you can use AppScript to extend the functionality of existing Google tools. It's pretty cool. If you want to see a longer version of this talk, because I only had 45 minutes today, but I have like an hour-long version of this talk, maybe 90 minutes. But the other thing that you probably want is the slide deck. So the QR code here is for the slide deck, or the short link as well too. And then up in the upper right corner again is the barcode and short link for the open Google Doc. And my daughter says hello. She loves drawing anime characters. And yeah, that's it. Thank you very much. And Amrita, I'm going to turn it back over to you for questions.
Thanks a lot, Wesley, for the insightful talk. I personally find it a great overview to understand how to better make use of the Google Cloud Platform. So yeah, we have a question over here from Rachel Chia. Yeah, so Rachel is asking, as an end user, how can she transcribe English speaking or Mandarin speaking into English and Chinese language transcript using Google Service? So currently they're using this regularly for video productions. And yeah, she has more to add on to it. Yeah.
Okay. Yeah, I think she can use the speech to text to turn that into a string. And then you can use the Google Translate API to translate that into a different language. And then if you wanted to, you could use the text-to-speech API to turn it into spoken Mandarin or something like that. So you have to you're going to have to chain together some of these, right? And then if you want to understand the text that was spoken, then you would use the natural language API for that. So for sure, you would probably use speech to text and translate. And then you may want to use text to speech and maybe natural language.
All right. Thanks, Wesley, for answering that.
Sure.
Rachel, I hope that helps. Yeah, so we have another comment. Okay, that's from
YouTube?
Rashid. Yeah. So, okay. Rashid wants us to add it to a playlist. Sure, Rashid will make it into a playlist because we have many more episodes to come, and Wesley would definitely be joining us in future as well. So I hope
boy.
you're all looking forward to that.
So much pressure.
Yeah, so that's about it for now. So if you have more questions, feel free to reach out to Wesley, or you could also post it on our page on GDG Cloud KL, or also on the chat as well. So thanks again, Wesley. I loved your talk. It was super fun. Yeah, so next up we have our speaker, Albert Padin.
Okay,
so
I'm going to go on mute.
Yeah.
I'll see you guys,
Okay.
and I'm going to stop sharing.
Thanks, Wesley. So, hi, Albert.
Hi.
Okay, so now that we have been enlightened on how to build with all of Google Cloud, now we have Albert talking on GCP machine learning APIs. And let me, okay. So I hope all of you can see the screen shared. And Albert, before we start, could you please share a little about yourself and run us through the talk today?
Yeah, so Wesley did a wonderful presentation. He had slide deck. I'm actually quite the opposite. I don't have slide decks. I don't have the time to prepare them. So I just go and do live demos. That's what I do. So yeah, sort of to introduce myself, I would go to my website. This is our company called Symph. If you go to About, you click that, you see me. That's me right there. So if you want to know more about me, you scroll down a little bit more, you get some marketing, blurbs over there, and then you finally see me, and that's me right there. Hello. And also, this is my Facebook account. So facebook.com/Albert Padin. And if you visit it, it's still a black screen. But yeah, same picture. My bio, founder CTO at Symph.co, and Google Dev expert for cloud and machine learning. That's it.
All right. Okay, so I'll remove myself from the stream, and the stage is yours.
All right. So today I'm be speaking for about roughly 30 minutes or maybe less, but I'll go through some demos. But before I go through the demos, I'm just going to give a story of a background of what is machine learning. So I have this picture. This was in Singapore, and I was asked to talk to some kindergarten students and asked to explain like what I do and tell them about what artificial intelligence and machine learning and how that works and technology. And I was super, super pressured because how do you explain machine learning to kids, right? And not only kids, like these are really small kids. So I had to go and like try to break it down as simple as possible. And today I'm going to give the same example that I did to them to you. So our first question I asked them was, okay, hi everyone, who here knows what a lion looks like? And everybody was like, me. I know what a lion looks like. And I was like, okay. Why do you know how a lion? Why do you know? How do you know that a lion looks like that? Teacher, because I saw a lion. Like I saw pictures. Teacher, when we went to the zoo last week, it's like, oh, okay. We don't want to go through your whole zoo story, but okay, we know how a lion looks like because you've seen a lion or you've seen pictures of lions. That's interesting. Cool. Now, next question. Who here knows what an elephant looks like? And everybody again was like, me. It's like, wow, everybody knows how an elephant looks like. How do you know an elephant looks like that? And they were like, oh, because I saw an elephant. Teacher. Like I went to the zoo. I was like, oh, okay. You either saw an elephant in real life or you saw pictures or videos of an elephant. So that's pretty cool. Now, the third question is, who here knows what an aardvark looks like. And everyone was just silent. They were confused. They were like, well, what's an aardvark? And I was like, do you know what an aardvark looks like? And I'm like, is that food or what is that? And so I was like, why do you not know what an aardvark looks like? And they're like, I don't know what an aardvark, teacher. What's an aardvark? Like, see, you don't know what an aardvark looks like because you haven't seen pictures or videos of what an aardvark is. So to satisfy your curiosity, here I'm going to share what an aardvark looks like. So aardvark, and that's how you spell it. And there you go. That's what an aardvark looks like. It's basically like a cross between a pig and a rabbit, and I don't know. But now that I've shown you what an aardvark looks like, you now know. Similarly, machine learning works in this way. Machine learning, basically, the machine is like designed like our brain, where we give it data, we give it examples, many examples of the data, like pictures of aardvark, pictures of lions, pictures of elephants. You give it a lot of data, and the machine eventually learns the patterns of what an aardvark or a lion or an elephant is. So in this case, it's able to tell that an aardvark is something that has like a snout, has pointed ears, and this kind of arm and this kind of body. And it may also look like this in different situations. And the machine is able to learn that, given that you give it a lot of data. And then the next time you give it a picture of an aardvark, it is able to say, I know that, that's an aardvark. And that is why machine learning needs a lot of data, because you need to give the computer a lot of examples so that in the future, it will be able to predict what new data is. Okay, so now that you know what machine learning is and how it works, like a kindergarten student, let's move on to what are the offerings or the products of Google that can help you with machine learning. So the first one is a product called TensorFlow. So TensorFlow, let me just reload everything because it turns out like all my tabs reload whenever I leave them for a little bit. So let's preload all of them to have a better experience later. Okay, now let's go back to TensorFlow. Okay, so TensorFlow is machine learning. It's an end-to-end machine learning framework. So now it's actually called a platform. Back in the day, it was just a framework. Now it's a platform. It's grown. So what does TensorFlow do? Well, TensorFlow does is that enables developers to code and make machine learning models using JavaScript, Python, and deploy them into the cloud, deploy them into mobile, deploy them in backend systems. All right. So instead of telling you what it is, I'm going to show you what it can do. Let me bring up my Finder. So over here, I have what I call Noodles AI. So Noodles AI, what we're going to do here is we're going to train a model. We're going to create a machine learning model that can detect what a picture is, whether it's a picture of noodles, what kind of picture, noodles. So for example, here, I have a pictures of ramen. So ramen noodles, I don't know if you know what ramen noodles are, but these is like really tasty, yummy Japanese noodle dish. So these are pictures of ramen. And I want to thank my wife for helping me gather all of these pictures. Oh, look at that. Aren't you guys hungry? It's about lunch. Okay, and then the other one is similarly, it's also noodles, but this is a local delicacy here. Not a delicacy, it's a local food here in the Philippines, and it's called pancit, Pancit. All right, so it's kind of like a dry ramen. There you go. Oh, look at that. Oh, so good. So now I have about 100 images of each. I've gathered 100 images of each type. So I have 100 images of pancit. I have 100 images of ramen. And what we're going to do is we're going to use a model called Inception V3. And we're going to use TensorFlow to retrain the model so that we'll show the model many pictures of pancit and many pictures of ramen. And then it should be able to tell, if we give it a new picture, what kind of noodle dish it is. All right, let's do that. So let's open my terminal. So I have here Noodles AI open. So let's see. I have a cheat sheet here actually. So let's do cat command. Okay, so here I have first installed TensorFlow. So I've already done that. Number 2, put the folders with images in categories. The name of the folders will be the classifications. So let me just review that I've done that. So, okay, I have here categories, and then I have the classifications, pancit and ramen. Great. Then third, we run this command, and we do what developers do best. We take this, and we copy paste it, right? Paste. Hit that enter key, and there our model is running. Whoops, no module name TensorFlow. That usually happens. The reason why is we don't have my Python environment activated. So let me just activate that quickly. There you go. And let's rerun the command. Press enter again. And now it should work. Fingers crossed. All right. It should work in a few seconds. Right about now, it's probably loading up the TensorFlow model. It's putting it in to the CPU. But my CPU is being used by the streaming software that I'm using. And there you go. So now it's creating the bottleneck. So these are the files that are the image files are being run through the model and being stored in this bottleneck files that they are called. So I told you we have 100 images of each. So now I expect roughly 200. So now it's doing the training. So training, it's trying to adjust the patterns in the model. We call these patterns weights. Like how much do I weigh? Weights. Okay, we call these weights, and they're adjusting the weights in the model, the variables in the model, and adjusting it to focus on what a pancit is, the differences between a pancit and the differences of the pancit has against a ramen. So while this is playing, I'm gonna play some background music just to hype us up, you know. All right, let's play some background music and let's get this, because this is gonna take maybe about like 20 more seconds. So our command over here, we told it to run about 500 training steps. That's not a lot. So now we're already 140. Oh boy, it really gets slower actually when I'm streaming. So go CPU, go. Okay, what's the ideal number of training steps? Definitely more than 500. This is where you as a machine learning engineer would have to tweak these parameters and see maybe 1,000 steps would be better. It depends. It really depends on the number of images and training data that you have. Since 200 images is just a small amount of data, then 500 in our case will actually do fine. All right, we're now halfway there. So thrilling. All right, now let's alt tab a little bit here, and then let's show. Okay, let me minimize the music. Okay, pause the music. So you can actually do what I am doing. If you Google retraining in image retraining an image classifier in TensorFlow, if you Google that, you can actually see that and see the actual code base here. All right. So I'm not showing you this. I'm just doing the demo, but you can actually do this. Right. It's not exactly as what I have because this one is more modern and it's much easier. But I like to do it old school. Pretty much doing the same thing. Okay, here we go. We're now at 370. So let's play back that music. Okay, just 100 more to go. In fact, training is now the new compiling, right? Before, when we were programming and your boss would walk up to you and be like, why are you doing nothing? And you'd be like, sorry, machine learning engineers, you press enter, it's running, and boss like, what are you doing? Why are you doing nothing? And then you go, boss, it's training. So, yeah. Okay, ideally, you would also run this in the cloud so you have more powerful machines. But since this is a local demo, we're just running it here. Okay. All right. Okay, let's pause the music and let's see if this actually works. All right, this is a live demo, so I don't know if it'll actually work. So now let's put back our command, cat command. And so to predict, what we do is we run Python label image.py, and then we insert the file path to predict here. So why don't we find an image in Google, right? Like find something here, say ramen. And usually what I do is I just keep scanning here and I ask my audience to stay stop. But since you guys are not over here with me, so I'll just close my eyes and then scroll. And then I'll just stop here somewhere. Okay, what happened? All right, well, my screen is still moving. Okay, that's not ramen. Okay, here. Let's see this one. Okay, I'm gonna screenshot this one, and wow, it even has a little bit of fish in there. Let's screenshot that. So I've screenshot that. Okay, let me test it if what happened there. Okay, let me see if it's in here. Desktop, desktop, desktop. Where's my desktop? Okay, it's over here. Okay, desktop, and we have a picture of that. Great. Okay, now let's put it there. Whoops. Let's copy paste this one. I forgot to copy paste. Paste, do what developers do best. Hit enter. And is it a ramen or a pancit? It's a ramen. We know it's ramen, but what does the machine think? The machine thinks it's dun 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 dun. It takes so long. Huh? It's ramen. Correct. Give the machine a round of applause. Awesome, awesome. Now let's do the reverse. What if it's just always saying ramen, right? So we have to make sure that it can also tell what pancit is. Pancit. Okay, again. Now we do some scroll, 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 close my eyes, and stop. This one. Okay, that looks like fried rice, but oh well, I think it's pancit. Okay, there you go. All right, let's screenshot that bit. It's okay. Now we have that. Let's go over here. Let's go Python label image.py, and let's give it our pancit photo over there. Okay, hit enter. Dun 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 dun. This one's pancit. So let's see. Fingers crossed. Machine knows what it's doing. Ramen or pancit? It should be pancit. Dun 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 dun. Dun dun. All right, pancit with 99% confidence. Now that's pretty cool. But wait, there's more. What if we give it a picture of, let's just say, our organizer, this guy. This guy, I think this guy's from Malaysia. He just added me, and I think it's because of this live stream. But high tech, I don't know if you are, I hope you're okay with this, but I just click your profile, and now we're going to take your photo and see if what does the machine learning think of you. Are you more like a pancit, or are you more like ramen? Looking good, by the way. Okay, here we go. Let's go over here. Let's type Python label image.py, and then let's see. Make sure we got the right photo. All right, there you go. Tech, looking good. Set it to the machine. Are you? It can't say tech, right? It has to say pancit or ramen. So let's see what it thinks. The machine is now trying to decide what this photo is, and it thinks it's 73% ramen, 26% pancit. You're more looking like ramen, right? But why does it do that? Why doesn't it say tech? Well, just like kids don't know what an aardvark is unless you show it pictures, it doesn't know what a person is unless you show it pictures or give that data. So right now, its whole world, the model only can tell between ramen and pancit. So whatever thing you give it, whatever input you give it, it will only try to fit it within the space that it knows. And in this case, it's pancit or ramen. All right, so that's TensorFlow. If you want to learn more about it, it's over here. You just go to tensorflow.org. There are some tutorials over here in the Learn. You can go ahead and do that. The one that I just did is in here called the retraining an image classifier. So now, what if I don't want to do code? What if I'm a developer and I just want to get things done quickly, right? So there's also stuff for that. I know Wesley talked about Vision API, so here we're gonna demo. It to you. So over here, what does Vision do? Well, you send it an image, and it'll give you all sorts of information about that image. For example, let's give it a picture. Let's go to. Okay, I'm gonna thanks Tech for your participation, for volunteering without actually like volunteering. So let's go to Facebook, and I'm gonna go to GDG KL. There you go. There you go. Click that. Oh, I missed it. GDG Cloud KL. Oh. My keyboard is lagging, but let's just wait a bit. GDG Cloud KL. And here you go, GDG Cloud KL. And let's take a screenshot of a photo over here. Oh, we're there. Okay. Up next. Hi, Shafraz. I just saw you there. Okay, that's me, but let's get something else. And that's Wesley, and that's both of us. So let's take this, put it over here. I took a screenshot of that, and now let's go back to Vision, and let's drag it over here. Okay, let's drag that file. Okay, let's see what Google thinks of this. Da-da-da-da-da. There you go. So now we're doing sending the image to Vision API. We have to click I'm not a robot because of this demo. But when you're hitting the API directly, you don't need to go through that I'm not a robot thing. Okay, so great. So it detected some faces, 2 faces, mine's and Wesley's, and once it's even does emotion detection, so you can tell that there's joy, and there's both of us are quite happy. We're quite happy to be talking to you guys. Thank you. Now, what are the objects in the image? So there's 2 objects. There's person, 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 and there's clothing. I'm happy that we are people with clothing. That would be dangerous to not have clothing. Labels. Okay, well, we got some nose there, a fish expression, an organism smile. So these are just labels on the entire image. Logos. We have a YouTube, a Merkabarn. I don't know what that is, but it's so funny. He did detect Facebook logo. Text is there. Then it extracted the text, right? So GDG Cloud Kuala Lumpur, and so on and so on. All the text in the image, and then there's this thing called Safe Search, where it basically tries to detect whether the image is safe, right? In the sense of number one, is it an adult? Does it contain adult content? Very unlikely, okay, because we have clothing. Spoof is when like you are making fun of something, like for example when you combine Donald Trump's hair with Kim Jong-un's face, like that's a spoof. So you can, some people find that offensive, so we can detect if there's that. Medical is when you're showing something that's like a surgery, then some people don't like that. Violence is like when you're seeing something that's violent, obviously. Racy is more of like when it's almost like adult, but not yet there. It's almost like adult with clothing, if you know what I mean. Okay, but you can look at that in more detail. So that's the Vision API. Let's give it another photo. I'd like to give it another photo here. So we'll reset it, and we'll get another photo over here. Let's look at some photos of your meetups, right? Let's go over here in photos. Let's see if we can get some. I miss meeting up in person, so let's see if we can get some meetup photos in here. Okay, I have some. Let's find a group photo. Like okay, wow, hello people. Okay, this is some group photos. This is interesting. Let's see something where. Okay, well, let's see. I'm having a hard time choosing. Don't you guys have a hard time choosing when you're asked to choose? Okay, last one over here. Okay. Okay, this one. I like this because it's a group of people with like different profiles. Okay, we have here. All right, let's take a screenshot of that. All right. Okay, now let's upload that. Ta-da. Here we go. There's a screenshot, and let's. Okay, uploading. What does Google Vision think of this photo? What are the properties that Google will return? So one thing, it returned faces, and this is really good because if you notice this guy over here, like over here, this guy is not even facing us, right? But Google can signal detect that there's a face in there. So that's pretty cool. And most of the people are like, oh my gosh, they're first person, no joy, no expression, no emotion. This one's possible happy. Face tree, I'm not so sure if they're happy talking to each other, guys. Except this one guy, face number 6, very happy. All right. Okay. What else does Google tell us? Objects. Well, this is a person, person, person. Okay. Pants. They're wearing pants. That's good. Top. What's the top? Okay, this one over here. Yeah. Okay, that's the fast. Labels. What are labels? So they're automotive design. That's interesting. Why does this look like automotive? This maybe that's when they're trying to design a car, they always huddle up in that position. So it's really related to what the data is given. But Google is giving us like these broad generic categories. So there's a hat. So there's a hat over here. Eyewear. Somebody's wearing glasses over here. It's a crowd. Yep, engineering. Looks like engineers. Maybe that's why it's automotive design. Okay, event, baseball cap. Okay, we got it. Next, we have text. Now, this is pretty cool because if we zoom in over here, remember his shirt? His shirt has a word, it has a brand, and it says Founds, right? Founds. And it's pretty small, but if you actually look into it, it says Found 8, found with the letter 8, but it's detecting as a found. So slightly incorrect, but I give Google credit for this because it's so tiny, it's still even able to detect it. All right. Next, we have safe search. Okay, very unlikely, very unlikely, very unlikely. Everything it's very safe kind of image. So that's Google Vision. Okay, you hit an API, you give it an image, and it'll be able to give you um, these properties, this information back. Okay, up next for Vision, we have this thing called Document AI. Now, this is pretty cool because for me, this is one of the use cases that I find very interesting. So, for example, we give it, what you do is you give it like an invoice. So, I don't have a sample, so we just click, don't have a document, try one of our samples. So, I click here the invoice. It's uploading an invoice. Okay. And for the sake of this demo, we'll use the sample that Google gave to us. But it's a sample of an invoice, and Google will return a structured data. So it will not only return like blobs of text, but it will actually give us key values. So for example, supplier name, Acme Plumbing, supplier address. So it's able to tell that all the way until like amounts, dates, due date, payment terms, purchase order, the line items, and multiple line items, right? The line item unit price, clear, and like the total amount, freight amount, and all that. So that is pretty cool. So that I don't have to submit the document, get OCR, map out the zones, which each one's mean, right? Google Document AI does that for you. Love it. Pretty cool. Okay, now we're done with vision. Let's go to speech to text. So there was a question about speech to text a while ago. So I'm just gonna do a quick demo of this one. So speech to text AI, speech to text API, we give it speech, it converts it to text. So I'm looking here for the demo. Where's the demo? Demo. There you go. Here's the demo section. Okay, so we're gonna use microphone. I'm gonna speak to it. So let's go English and let's start. Okay, I have to click I'm not a robot. Here, let's talk to it. Hi everyone. Thank you for being here. And I am so happy that I can talk to you guys. And this is pretty cool. It's actually understanding what I say, even though I speak so fast. Okay, this service is in the middle. I spoke too fast. Again, stop. So it's just a demo. Probably too many people are speaking to it right now. Okay, so well, that's a speech to text. Now let's go to text to speech. I'm looking at my clock and I can see like 3 minutes to go. Speech to text. So let's do this. There you go. Let's change it to, hi everyone, glad to be here. Now the cool thing about this is we can change things up. So let's, for example, let's give me, okay, let's play this one. Speak it.
Hi everyone, glad to be here.
I hope you heard that. Okay, next one, we can change it to a female voice. There are different kinds of voice.
Hi everyone, glad to be here.
Now, sometimes I like to play with this, right? What I do is I change it to, let's see if there's Malaysian in here. Malaysia. No, Bahasa, let's see, Bahasa. No, no, but basically we can change accents. So for example, this is the accent in Filipino. Well, it's changing the language, but let's speak it.
Hi everyone, glad to be here.
Yup, that's exactly how we mostly sound. Not me right now, but that's kind of like how we sound. And you can change that. You can increase the speed, like make it sound faster. You know, when.
Hi everyone, glad to be here.
So for example, this is what we people usually do is they put here, drink moderately at the end of the ad, right? And you change it and you make it really fast. So you have to make it, to just at the last part of a video.
Drink moderately.
Okay, and then you've complied. So something like that. Okay, and the last one I wanted to show you, but this is not going to be a demo, but rather what happens if I want to, I don't want to use Google's Vision API, but I want to have like I want to use Google Vision API, but I want the data to be mine. I want the data to be mine, and I want the mod it to be constrained. So, for example, what we do is we have a use case where we're trying to detect different types of valid identification cards in the Philippines, like passport, a Philippine passport, a Philippine driver's license, a Philippines identity card. And these are, and I just want it to be that. I don't care about like a American or a Malaysian or any other country's identity card or any other identifications for that matter. So what I do is I use Cloud AutoML, give it the data, so AutoML Vision, give it the data. I have like thousands of pictures of this different labeled images of identity cards and identification. And I run it through AutoML, and within, I think, a few hours, it's able to create a model that I call with same convenience that I can call the Cloud Vision API. And we just click, 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 not having to learn anything to code to run the machine learning algorithm. So yeah, in summary, we went through TensorFlow demo, we went through Cloud Vision, we did document AI, we did speech to text, and we did text to speech, and I've showed you AutoML. And yeah, what's next is for you to try it. Okay, so yeah, that's it from me. And if you want to add me up on Facebook, please do message me and say that you tune into this live stream. Message me and say that we met virtually in this live stream, and we can continue the conversation in Facebook Messenger if you want. So please don't just add me randomly, or else like I won't know that you're from this event. So thank you, Amrita. Back to you.
Thanks a lot, Albert. I had a lot of fun. And yeah, I'm sure all of our audience here were just as excited as I was listening to both of you talk. So Wesley, I'll add you to the stream as well.
You probably didn't see, but I was laughing like crazy. Albert is just
Yes, I
incredible.
did.
I almost fell off my chair.
I noticed that you were drinking, and when Albert said something, and you nearly choked.
Oh my.
Yeah, so thanks again, Albert. Thanks again, Wesley, for joining us today. It was definitely an amazing way to kickstart our Cloud Talks KL series. I truly appreciate both of you joining us today, and I'd like to thank our participants as well for joining. I know it's Saturday morning. We usually like to, chill, but I'm sure, no one would regret joining this talk, because what better way to start your day, right? You learn stuff while having fun as well. So thanks everyone once again. We've shared the feedback form, so feel free to quickly just go through that and let us know what you like about our event, and what is it that you want from us. We can, provide you with more topics, and let us know what you like so that we can help you out as well. And yeah, that's it from me. Albert, Wesley, any last few words before we end the stream today?
I don't really have any other than based on seeing what Albert did, anybody can try this stuff, especially the demos on the home pages of each of the products. We try to make it easy for people to get started. What he didn't show you was that you can also see the JSON payloads as well too. So you can cut and paste that stuff and drop it into your code right away. So you don't even have to code that part. You just have to get access to the the whatever API key or OAuth surface account or something like that. That's really the only thing that you have to the only challenge you have. But we want people to be able to get going and get something working in like less than 15 minutes, basically. So give it a shot. I think it would really help out. Your jobs can be much more fun if you have more fun playing with toys like this. So I love all the ML stuff. So glad to help.
Yeah, from me, talk is now over. It's time for action. So go and do it.
All right then. So we can see in our comment section that all of our audience really enjoyed this. So stay tuned and feel free to let us know and ping us if you have any questions. And also for speakers who would like to give a talk next time, feel free to reach out to us as well. So on our feedback form, there's a particular section where we're calling out for volunteers who would like to be part of this community and to be part of the organizing community. So if any of you are interested, just click on the yes button and we will reach out to you very soon. Once again, thank you, everyone. Hope you have a great weekend. And that's it from us. Bye.
Bye-bye.
Take care.